Section AA is about linear versus exponential. A couple of definitions to start us off are linear. This is when something is increasing or decreasing by the same absolute amount in each unit of time. Exponential is it increasing or decreasing by the same relative, and by now you should remember relative every time you hear or see it should automatically think of percent, the same relative amount in each unit of time. Also, remember doubling is the same as increasing by 100%. So if something says doubling, then you think exponential or tripling because it's increasing by a percent even though it doesn't have a percent sign attached to it. Our first example is comparing two towns. Town A is increasing in population by 500 people a year. Town B is increasing in population by 5% every year. So, using the definitions, town A is increasing linearly and town B is increasing exponentially. They both start with the same population of 10,000 people. And here's our graph. Town A is this line, town B is this exponential curve. Now remember, both of them started at 10,000. So town A is increasing by 500 people a year. So if I could come over 1 year, it increased up 500. Over another year, another 500 up, and so forth. Over, up 500. Over 1 year, up 500. And it grows very steadily and in the exact same fashion. Every year it goes up 500. And that's why it's a linear increase. Now if we talk about town B, 5% every year. So I'm going to increase by 5%, and these will increase rather similarly for quite a while. 5% is not too much, and so it's about the same. Now when I start getting into the higher numbers, 5% increases dramatically because the larger the number, the larger the 5% it adds to it, just like we did in the last section of compound interest. Let's move to our next example. If a high school has an increase in its enrollment by 50 students each year, and it starts at 750 students, how many students will there be after 4 years? And is this a linear or exponential growth? So if it's increasing by 50 students the first year, the 50 students the second year, 50 students the third year, and 50 students the fourth year, we can say off the top that this is a linear growth. And I've already written this down here and highlight it in some fashion for it to be the answer. Now let's find how many students there will be after 4 years. We can use unit conversions here because if I have 50 students per year and for 4 years, using my insert an equation, I can get this to 50 with students over years times 4 years, having one on top and one on bottom. I can use the strikeout feature to cross out the years for my units, and I'm left with 50 students times 4 gives me 200 students. So it's increasing to by 200 students with my original total of 750. 750 plus 200 gives me a total of 950 students after 4 years. The next example, number 2, if the price of grocery items is increasing by 3% a year, which is the same as inflation, and milk cost $2 a year ago, what is the cost now? And is this linear or exponential? If it's increasing by 3%, this is an exponential growth, which I've pre-canned and even highlighted so that we can see that's the answer. Now, if I have something increasing in a percent every year, this we can use our compound interest formula. Now, some of you are thinking, why are you using the compound interest formula with the n, considering that this is increasing every year? I could use the annual one, but I like to just memorize this one and change the n to be 1 for the annual. Then I only have to memorize one equation. So A is amount final. I want to know how much milk will cost now in a year. So final amount. And the principal is what it started with, or the original cost. The initial is $2. So we can type it in as 2. Now I know some of you have started with me from the first video, but I'm going to assume that not everyone started on the original video. So I'm going to come up here and show you again how to insert an equation. Now, because I already have this one here, I could just copy and paste, but I'm going to type it in so that we know, so that I am confident that everyone watching this video is up to speed with me. So I insert my equation and just start typing. Capital A equals, I'm going to do 2. I can do Shift 9 to get a parenthesis, or come up here to do a bracket and get parentheses. Type in my over button. Using the arrow over, I have 1 plus, now I need a fraction, pull in my fraction, again my over arrow button, and I want 0.03, which is what it was increasing, same as inflation, down arrow or over, 1. Now I want to raise all of this to a power. If I come up here and just do a script, it's going to say I need something to a script and give me something. So I don't want that. I'm going to highlight this and give myself the superscript for that part. And n was 1 time a year, and I want the cost now, which is only a year later. So times this by 1, and I should get the answer. Now that you know how to type it in, I'm going to show you how you can do this without your calculator. Right click and copy, and then go into Microsoft Excel. I have some things pre-canned for later in the section, but I'm just going to pick any cell on here, make it work like a calculator by pressing equals, and paste by Control V. Bring this over and type multiplication, which is Shift 8 or above your keypad. Either way, because Microsoft Excel won't calculate it without that. And it looks like everything else is good. Press enter, and I have 206, which I have in here as the answer. I'm going to delete that so that my notes continue to line up. And once again, make sure that this is the answer. Highlight it in some fashion. Turquoise sounds good. All right, now this is convenient because what would it cost after 100 years? Now that I've typed this in for you once, I'm just going to copy this and paste it down here to show you how to speed things up in yours, and change y to 100. So use my over arrow button, use my over arrow to get out of the exponent, press equals, copy and paste, or since we already have it in here, we can come back and change this to 100. Press enter. Just for fun, we can say format this into currency and then copy. Oops, copy. Oops, not that. Copy and paste. Control V. It's good to see the teacher do it wrong sometimes so that you can laugh at yourself. There we go. Not everyone can do everything, especially with technology, perfectly. There we go. So here are our answers. I hope that in 100 years a gallon of milk doesn't cost $38, but let's move on to the next example. The value of some sort of equipment is depreciating by $200 a year. If it was bought 3 years ago for $1,000, what is the value today? And is this linear or exponential? So I'm decreasing by $200 every single year. That's an absolute amount, which means this is a linear, and I've pre-canned that for us. This is a linear example. So if I have $200 per year or a year, I can use my unit conversions again. $200 over every year for 3 years times 3. I can highlight this, strike it out to show that the years cancel, one on top and one on bottom. I'm left with $200 times 3 gives me $600, and this is depreciating. It started out at 1,000, so 1,000 minus 600 gives me a total of $400 for the value today. Let's move to the next example. The memory on hard drives has almost doubled every 2 years. If today it has 800 gigabytes, what will it be in 6 years? Is this linear or exponential? If it almost doubled, doubled means, go back just to our little reminder, increasing by 100%. So that means exponential. And if you were watching closely, you saw that this is wrong in my notes. So let's change it to exponential. And let's re-highlight it. And it's always nice that we can laugh at those little mistakes. All right, so it is exponential. If today it has 800 gigabytes, what will it be in 6 years? Now remember, it's doubling every 2 years. So in 6 years, I have 3 doublings. So let's just double it. 800 doubled gives me 16. That's one doubling. 16 doubled to 32. That's one more doubling. One more gives me 3 doublings. 32 doubled is 64 gigabytes or 6.4 terabytes. Let's move to the next example. The price of a TV falls by 25% every year after you buy it. Let's say there is a TV priced at $2,000. Today, what will that same TV cost in 2 years? We have two different ways we can do this. Some of you are very comfortable and confident doing $2,000 times 0.25, which will equal $500. And then you say, now I take my 2,000, subtract the 500, which will equal 1,500. We've been doing that for a really long time, but in the latest section we talked about of versus more than, and I can take my $2,000 and times it by 100% of the $2,000 is the full price, but it's falling by 25%, which means I'm really multiplying it by 75% of the value, which gives me 1,500. And you don't have to subtract at the end. Now I take this 1,500, which is the cost after 1 year, and I want to find it after 2. So I bring it down to the next one, times it by 0.75, and I get 1,125. I could use Excel. In this example, it's really easy. We only have 2 years, but what if it asked for it after several years? So let's try it. This one we already did. So I've pre-canned a couple of things up here just to remind myself the cost of the TV is $2,000 and the value is going to be 75% of it because 25% off leaves me 75% of the value. Year 1, year 2, and we can go a couple of years. Now though that I have some sort of a pattern set, I can left click here, hold the left click down and pull it, and Microsoft Excel will see the pattern and fill it in. So I could go through and find after as many years as I want. Year 1. After 1 year, I have $2,000. Actually, let's do something a little different. Let's move the $2,000 here for year 0, so it hasn't changed anywhere. Just for fun, so that I can drag my equation down with me. So here I'm going to say reference the cell one above. So this is cell C4. I'm going to reference the cell one above it, which is C3, and times that by 75%. Now, because the 75% is always going to be what percent we're taking of the value, I want to highlight that or just keep my cursor next to it and press F4 to do an absolute cell reference. This says that the dollar sign says I'm absolute referencing the column E. This dollar sign says I'm absolute referencing row 2. In combination of absolute referencing the column and the row, it means it will always be this column, this row, E2. If your F4 button isn't working, there are some laptops that need I think function F4 or control or an alt, or I don't remember. So you might want to play around and find what it works on yours, but most of them should be just F4. If you're having trouble still, feel free to type in Shift 4, which is the dollar sign function, and just make sure that you're absolute cell referencing the row and the column. Now I can press enter, and there we go. We already got 1500 on the previous one, so we know that's right. Now that I have this cell referencing this above and absolute timesing by 75%, I can get my crosshair down here, just move my arrow, my mouse over, left click and pull, and it pulls it down. And it takes 75% off the next one, which we already know is 1,125. But if it had asked for more, we can go down further. Also, I find this kind of helpful when we move into doing your projects. If I want to, I can come in here and format because we are talking about money, currency. There we go. All right, let's move back to our next example. Here we are. Okay, Roman numeral 2, the impact of doublings. Parable 1. Let's suppose we have a hero to headless in 64 easy steps. In a well-known story, the inventor of the game of chess was asked by his well-pleased king what reward he desired. "Oh, not much, your majesty," the inventor responded. "Just place a grain of rice on the first square of the board, 2 on the next, 4 on the next, and so on. Twice as many on each square as the preceding one. I will give this rice to the poor." For the people who don't quite know, a chessboard has 64 squares. The king thought this was a modest request, and indeed he ordered the rice to be delivered. So down here I have a table working on our squares and grains of rice. Now we can go ahead and do this by hand, or we can use Excel, which is a really fancy tool. And let's come in here. I've already pre-canned a couple of things. We need square, grains of rice, total grains, and the formula. All right, the squares. We're going to start with 1 square, 2 squares, 3 squares, and now if I highlight these, just left click and pull, highlight those, Microsoft Excel will see the pattern, and just continue adding by 1. And we need 64, and Excel will tell us on the right hand side of where I'm pulling how many I've gotten to. Scroll up to the top. Now grains on a square. I know we had the formula on the other page, but we're going to come up with it on our own. The first square has 1 grain. The second square doubles to 2. The second square doubles. 2 doubled is 4. Doubling that is 8, and so on. The first one, the total number of grains, there's only 1 on the first square. The next one, the total number of grains will be 2 on this square and 1 on this square. So 3. And this one will have 4 on this square and 3 from the 4, 2, and 1, or 4 plus 3. In fact, we could go ahead and make an equation here using Excel, not the base 2 that we saw previously, just so you can see there's multiple ways. I'm going to reference this cell to the left and this cell up to the top and add those together, which gives me 7. Or I could say add everything to the left. In this case, I like this one. So I'm going to equal this cell and add this cell, or now that I've already gotten my equation here in Excel saying the one to the left and the one to the right up, I can just left click or get the crosshairs and click and pull. There we go. All right, now let's go ahead and find some formulas. So this is 1, 2, 4, 8. All of these are from the base 2. 1 is base 2. I can put equals 2 raised to the 0. Or in this case, I could say my square, actually let's put that in parentheses, the square minus 1, because 1 minus 1 is 0. And the reason I did that is so I don't have to type in 2. It's already here. So this one I could say equals 2 raised to this square minus 1. Or just click and pull. Because I've already referenced the 2, subtracting 1 will continue to reference that. Let's make sure and see if we get more. 4 and 8. Yep, there we go. So I can just click and pull now, and it will continue to reference that. If you wanted to write it by hand, however, you would just say 2 to the and write 5 minus 1 as your exponent. Now let's find the formula for the total grains. I know we have the total grains here, and we could continue to click and pull because now I have these filled in as being my doublings, and this is adding the previous one and this. Okay, so let's look for more patterns. The total grains here actually aren't too far off from the next doubling. 7, that's only one off. 15 is only one off. 31 is only one off. In fact, it's continuing to be only one off from the next doubling. So let's find the formula by using that. Still using a base 2, so I want to raise 2 to something. Well, if this one is the next doubling and I subtracted 1, let's go ahead and use this without subtracting 1. But that only gives me 2 and I want it to be a 1. So I need to subtract 1 from the whole thing. 2 raise it to a 1, and then subtract 1 from the total will give me 1. Let's see if it works. I'm going to come down another one. Oh, it's working so far. So 2 being raised to the 2, 2 squared is 4, subtract 1, subtracting it from the total. Let's see if it continues to work. Yep, it's working so far. So I have two different ways in Excel of doing this. Or those of you who'd rather use your calculator, go ahead and use this formula, which is nice. Now that we have the formula, we don't have to go all the way to the end. We could come down here. Oh, press enter to get out of that so that you don't try and cell reference. Down here, I could just say I want to equal 2 being raised, and if I were doing this by hand, I would type in 64. Now that's in the exponent, subtract 1 from the whole total, and it'll give me my answer. Or I now have Excel, and I can get my crosshairs and click and drag. And because all of these are just fine, I'm going to left click and pull over here, highlighting all of those, and drag them all down to the bottom. And there's my answers. And these left two or right two columns should all match, and it looks pretty good. Down here, you'll see that these are in scientific notation. If you don't like that, we can change it, and they're getting a little crowded, so I'm going to make these a bit wider. And we start about here for all of them, and right click, format the cell to number. There we go. Oh, we need to make these even bigger. That's saying something about the amount of rice. All right, that is the total. And it matches this one. Perfect. So I'm going to copy, go back into here, and I can type in my formula because now we know it. It is 2, and I have a superscript here, raised to the 64, come out of the superscript, subtract 1 from the total, which equals total grains of rice. Control V to paste. I have a lot. I'm going to put in my commas so that we can find where we are. All right. I believe this is considered 18 billion. Yes, a large amount. And therefore, the king in the parable beheads the inventor of the game of chess instead. All right, let's move on to the next one. Sad story. Parable number 2, the magic penny. A leprechaun gives you a penny, you place it under your pillow, and it doubles every night. How much would you have at the end of the month? This one's a little different than the previous one. We could come down and do this one by hand by saying day number 0, he gave you the penny, which is 1 cent. And the next night, or the very first night, you put it under your pillow and it doubles to 2 pennies. And then the next night, 4 pennies and 8 pennies. Now we can figure out the equation by looking at these just like we did in the previous one. 1, 2, 4, and 8 are all base 2, but I do need to multiply it by a penny or 0.01 to give us the monetary value. So I'm going to take 0.01 and times it by base 2. Now to figure out, this is day 0, 2 to the 0 is 1. 1 times 1 gives me 1 penny times 1, or 1 penny, and so forth. The next one gives me 2. 2 being raised to the 1 matches the 1 over here, which gives me 2, and so on here. Or we could do it in Microsoft Excel by, over here I have pennies and nights. Let's say night 0, night 1, night 2, and now I have a pattern going. Microsoft Excel will see that. Left click and pull, bring your arrow button or your mouse over here, click once you get your crosshairs, and we wanted to know what it was going to be after 1 month, 30 days. So our penny starts out 0.01 here. The next night I'm going to press equals, reference the cell above, times it by 2 to double, and I can click and pull this all the way down. It keeps doubling. Or we can use our equation or function that we figured out previously. To find this by not using an Excel doubling every time per cell, we would do something with base 2. So base 2, now remember, base 2 to the 0 is 1. And that helps us 1 times, or base 2 to the 0. And I'm going to go ahead and reference this over here instead of typing in 1. We could, or 0. And now I need to multiply all of this to the penny times my penny. There we go. Let's go ahead and check it. And I'm going to highlight this in F4. Oops. F4 because I want to multiply everything to just the penny. And let's see what happens if I come down here. Let's see. So far it's matching 8, 16, 32, 64, 1.28. Okay, so this one would work. That's another way. Or we can just take this for the number value and go straight to the end down here at 30, press equals, and do my 0.01 for the penny times 2 being raised to the power. In this case it was just the day or the number. I can highlight it or I can type it in and have it calculate it as a calculator. Either way will give me a large number. We'll come down and just try this again. Let's highlight both of these, pulling them down, left click, pull, and you'll see in this case it should give us the same number. Good. So at the end of a month, let's highlight this format because we only need that one. Currency. Wow. Now that we have our commas in there, this goes over to $10 million. Copy, and at the end of 30 nights, you will have $10 million. I'm going to bring this over just a little bit to match up with my notes. Let's keep going. Let's just see what would happen after 50 nights. We could go back into Microsoft Excel and continue clicking and pulling down 50 till we get to 50, or we can use our equation, 1 penny times 2 being raised. Instead of doing our caret in this one, let's go ahead and do our superscript being raised to 50. Getting out of the superscript and equals. We can highlight this, copy, go over to Microsoft Excel, find a cell, any cell, equals to make it calculate like a calculator, And in this one, we're going to need to raise it to the 50 because it doesn't see the superscript. And press enter. Ooh, let's pull this out so we can see what it is. Now, I don't want to see it like that, so I want to format it. In fact, let's make it a currency. Wow! So we have hundreds, thousands here, millions, billions, trillions, 11 trillion. So let's copy and paste this back into our homework. Control V, 11 trillion dollars at the end of 50 nights. The power of doubling. Let's move to our third parable. Bacteria in a bottle. Suppose we have bacteria that doubles every minute, and let's say we start with one bacterium at 11 a.m. Bacterium because it's only one. Bacteria for multiples. And therefore we have 2 at 11:01, and so on. Our first question, if the bottle is full at noon, when was the bottle half full? If it's doubling every minute, then it was only 1 minute before at 11:59 that the bottle was half full. If there is a bacteria mathematician warning the others of their impending doom at 11:56, would they believe the mathematician? 11:56. Let's go ahead and use Microsoft Excel, although I know most of you can go ahead and divide by 2 over and over, figuring out what at 11:56. But just to show you again, we already did that one. Let's come up here. At 12, there is one bacteria. So at 11:59, we're going back by minutes, 11:58. We want 11:56, right? So we're going to highlight this now that we have a pattern set and come down to 11:56. If I have it being full or one bottle at 11:59, I'm going to take this and divide it by 2 or times it by 0.5. Either is the same. And it's half full at 11:59, 11:58, 11:57, 11:56. Should be dividing it by 2, 1, 2, 3 more times, which gives us 1/2, then 1/4, 1/8. This should be 1/16, and you'll notice it isn't showing. So let's go format the cell, change our fraction so that we have 3 digits. There we go, 1/16. So we can come back here. Would they believe you? Probably not. It's only a 16th full. So let's say no. Question 3. At 12 o'clock, you discover 3 other bottles in the room and send bacteria to fill them up. How fast will they fill up? So at 12:01. Well, at noon, it was 1 full bottle, so the next minute will be 2 full bottles, or using up 1 of your extras. Because you've used up 1 of the 3, you still have 2 full after that, and you'll end up with, at 12:02, you're going to fill up 2 more bottles, which uses up all 3. All 3 extras are now full. And so they will all fill up in a total of, all will be full at a total of 2 more minutes. Let's go ahead and highlight my answers. I haven't done that on all of these. Highlight, answer, and again, answer. Question number 4. Is there a way for the bacteria colony to continue doubling? And let's just go ahead and see how many there will be at just 1 o'clock. Let's go back into our Microsoft Excel and let's do time and bacteria. So at noon, let's start at 11. 11 o'clock, I had 1 bacteria. And you can see that I have this rather large because I was working on it. And I know it's going to get rather big, at 11:01, and we want, now that I have my pattern, left click and pull, let's go all the way to 1 o'clock. 12:30, and this is going to come up in military time as 13. Now let's see about the bacteria. It's doubling every minute, so I'm going to equal the previous one and times it by 2. And again, I'm going to do so on and so forth. If I click and drag it, it'll take the previous and times it by 2, which is doubling every time. Let's go ahead and format all of these so that they don't have a decimal. Let's format the cell. We can do number and get rid of the decimal. Sure, let's do that. Or we could have done general. And again, continue to double or click and drag like we did previously. The crosshairs, left click and drag. Or we can use finding the pattern and coming up with a formula. So if it's doubling after 1 minute, so here I get 2, 4, 6. These are just base 2. This is 2 to the first power, so equals 2 raised to the 2. And this was at 1 minute. So I'm going to take, oh, this is raised to the 1 power, which is the same as the minutes, 1 minute later. This one will be 2 raised to the 2. 4 is the same as the time, the minute 2. So I could come down here. How many minutes is it till 1 o'clock? Equals 2 being raised to the, at 1 o'clock, that's 2 hours after it started at 11. 2 hours is 120 minutes. Or we can use our Excel that we used here and click and drag. Pull it down all the way to 1 o'clock and let's see if those match. Oh, I've already formatted those cells. And like I said earlier, this is going to be a large, I'm going to pull it over so I can see them. There we go. I have 2 ways of writing it. The scientific notation, or I can write it out to be a huge number. I can take, let's take both of those and copy and paste them in so that we have 2 ways of answering the question. How many? Oh, and here's our formula, 2 being raised to the minute. Control V, we have 2 ways of writing that, and I'm going to move that over. Oh, it doesn't matter. In this case, let's just highlight those as being the answer. And because there's 2 different ways of writing it, I'm going to highlight it 2 different colors so that I know those are 2 different answers, just for fun. All right, so let's answer the question. Is there a way the bacteria colony can continue on if after 2 minutes, considering this question, if after just 2 more minutes, it filled up 3 more full bottles, and down here it shows us a massive amount. Can this continue on and on and on forever and ever? No. In real life, it just can't happen. So Roman numeral 3 are doubling lessons. It just can't happen in real life. It at some point will have to level off. And the key facts: exponential growth. The next doubling is approximately equal to the previous total, which we did when we found, let's go back into our Excel functions over here, when we were coming up with our answers. Here, we noticed that the 7 was almost the 8. So the next doubling is approximately equal to the previous total. And it can't continue indefinitely. It's just impossible in real life. Hope to see you for section 8B.